Welcome to this recording of the Coast Division virtual event, recorded Saturday, November 7th at 9 a.m. Okay. So what I want to do is I'm going to go ahead and start this and just kick it off for the meeting. And then after this slide, I'm going to go into this 3D thing. And I'm kind of going to try to keep that a little separate so that we can turn it into a clinic and put it up separately on our kind of our 3D clinic. So I'm going to pause for a second and start just because we actually have, what's interesting is we have more people watching these events on the video recordings than actually typically come to the event. So trying to make those nice. So I'm going to pause for about 2 seconds. Hi, welcome to the Coast Division Saturday virtual event, November 7th. Have an exciting day today. We're really going to focus on 3D printing. Jonathan Sauer is going to do an introduction, talk to us about different parts of 3D printing, and then we're going to kind of throw it open to the division to have people show what they've been doing and talk about 3D. And then separately, we're going to have just a moment for some PC board inputs for our board meeting this afternoon. Anyway, with that, let me jump into the 3D clinic. So welcome. This is a Coast clinic on 3D printing. Call it the good, the bad, and the smelly. I think it's really an interesting thing because there's a lot of good things about 3D printing, but as you're going to find out if you do resin, you've got to deal with the smells and other things. Jonathan Sauer is going to do a quick run across what 3D printing is, what the options are, and that's going to really help us understand, the choices that happen here. What's really exciting about 3D printing is whether you choose filament printing on the left or resin printing on the right, two different technologies, the prices are coming under $200. So if you look at an investment for a model railroading tool versus laser cutting or a cry cut, it's a very cost-effective solution. And the question is, does it have the right kind of power for you? And there's a whole series of questions here about what kind of technologies are there, what about the CAD applications, should you use a service, et cetera, et cetera. And then a little bit about 3D printing, for modeling, what can you model? And I think a big question, how does scale affect your 3D modeling use? We'll talk a lot probably about the differences in resolution and ease of use. So anyway, with that, I'm going to throw it over to Jonathan and have him start sharing. And he's going to do an intro to 3D printing overall and kind of let us understand what the options are and what the choices are. So Jonathan, I'll throw it to you.
Sounds great. Can you hear me? Might help if I come off mute.
You're fine.
I am off mute. Okay, there you go. Can you see my desktop?
Yes.
Okay, perfect. So hello everyone, or good morning. So I'm new to participating in this. I'm worked for Hewlett Packard for 32 years. I took an early retirement package, and I'm getting back into one of my loves, and that's model railroading. I've been dabbling with 3D printing for a long time. Many years actually, and what I'm going to do is just kind of do a quick walkthrough of what is it, kind of level set with that, give some examples, and kind of walk through this. I like interactive sessions, so I've got my chat window open on the side. Please feel free, if you have a question, throw it in the chat window. I'll try to answer that. I'll keep an eye on that as I go through. Already went through the agenda. It's really, what is it? What can you print? How do you get started? I'll walk through what my setup is, kind of my typical workflow, and then really, what have I learned so far? What are some of those interesting things? Time permitting, I can go through like a day in the life of actually how I did a particular piece. So what is 3D printing? Everyone here is probably familiar with CNC or machining, where you take a physical item and then you remove material. 3D printing is kind of the opposite of that. It's an additive manufacturing. And there's a lot of different technologies, and it's growing really fast. I actually have a dear friend of mine who works at Hewlett Packard Inc., who makes that machine down in the right here, which is a high-end. It can print metal and all types of really cool stuff. But from a hobbyist perspective, oops, somebody's got mute. Okay, so from a hobbyist perspective, there's resins, and that's a liquid-based type of printing technology. Then there's sprays and ABS and PET. PET is like what you make soda bottles out of, or fused materials that a printer like this one here actually deposits material. There's a growing number of what I call advanced materials. There's flexible materials. So I have actually print my own gaskets and stuff. It's a softer material. I've also dabbled with printing metal and wood infused. So you can get fibers or technology that has metal particles or carbon fiber or wood in it. And then you can do a lot more post-processing. There's a new emerging casting material. So if you print something, and this is on the resin side, you could print something that is, well, think of your lost wax, molds. So you can create a mold and it's like a wax material. So that's a new technology that's just emerging right now, and it's at a hobbyist price point. So the big question, what can you do with a 3D printer? Obviously, anything you can think of, given time and energy and of course money, you can print it. There's detailed parts, brackets, clips, enclosures, tool organizers, sound baffles, and I'm going to do a quick flyby with some of the photos. So on my workbench, this is all 3D tool holder, for paint and stuff like that. Pliers holder, all my paint rack in the back. This one I actually printed just last week. I was building a model, and I kid you not, I spilled over this 3 times, made a big mess, and I said enough is enough, so I actually 3D printed a little base, and I have built it since. I built myself and 3D printed a soldering filter. It's a carbon filter, so when I'm soldering with the, the resins, it just gets the fumes out, and then I add on an iPad. This is all off of your FDM types printers. That's where you have the spool of material, and it deposits it. I've also done things, oops, get out of this, next slide. Models. And so one of my other hobbies is building actual little models and stuff. And so everything you see on this, the stand here, all the detailed parts here, these lights, they're all 3D printed. This is a 3D printed piece right here. I just recently finished building a Star Trek model that I put LED lights in. I 3D printed pieces inside it and as well as a stand. And then this Saturn V engine, the F1 engine, that's all 3D printed as well as this piece here. Now, these models here, unlike the tool holders, these are all resin printed because you can get a much higher density with that. So getting into, more of the resin printing, gaming miniatures. So my son plays a lot of miniature games, and this is kind of how I ended up getting into 3D printing, is he wanted pieces printed. And so this figure and a lot of the pieces on this table, they are all 3D printed. And then from my layout perspective, I'm a fanatic of printing my own brackets and stuff. So, a holder for my meter for my power management on my layout, a Sprague holder. My recent thing that I did was a tester for DCC and made my little rolly things. And then, of course, holders for, throttles and stuff. My speaker baffle, this was one of the more fun projects. And so PBL, Jimmy, encouraged me to put sound in this little brass locomotive. And I got myself my nice little speaker. I put it in. It sounded okay. But how do you get something in such a small spot? So I just sketched out a little baffle, put the speaker in it, and the sound changed tremendously. And this is a custom baffle that fits the curvature of this roof. So it fits in really nice and tight, and it sounds great. So that's a great little example. Where I think the resin printing really comes in and what we need to think about, and this is the newest addition to my workshop, is the ability to print these small parts. And so this is an inch by, a half inch by an inch tall. This is even smaller. These are just really highly detailed. You can't even see the printing lines on them. And it was one of these inspirations. I did this model. Most of the pieces in here are 3D printed, and I wanted a printing press in the back room. And I got inspired by, chat groups, and somebody pointed me in the right direction of what to look for, and I found this piece and printed it, and now this model is actually complete. So how do you get started? Well, there's two ways. You can do a service, Shapeways, Ultimate 3D Printing, Craft Cloud, those are services. It can get expensive quickly. So for the models that I was showing, my rocket models, some of those I actually paid for Shapeways, and they were like $100 for the model. Compared to kit models these days, that's not that much. But if you're going to be doing a lot of that, that can add up pretty quick. On the other side, well, you can get your own setup, get your printer and the post-processing gear. So let me talk through my setup. I'm a Mac user, so I've got a Mac. Folks who use PCs might have a little easier time from finding pieces of software, but you can do it equally as well with a Mac. I started with a Monoprice 3, my first. That's your sub, $200 printer, 3D resin, or not resin, filament printer. I printed with that for about a year and a half, and then I upgraded to the PR USA SLA printer. That one is around a $700 printer. Huge quality difference between these two. So the $200 printers work great. You do have to pay attention more to the environment when you print. And then my latest addition was an Anycubic proton printer. I got that on sale last year. I think it was like $270 for that piece, so a little more than just your $200 or less, but it's a fantastic printer. I built my own UV cure box, so when you get into resin printing, you've got to cure it. So unlike the filament printers, it heats the material, deposits it, and then there's a fan that cools it, and it just kind of 3D prints out your thing. And then when it's done printing, it's done printing. You take it and use it however you want, do some post-processing. For resin printing, it actually is a liquid, and it uses ultraviolet light that cures a very thin layer and then moves to the next layer. But it doesn't fully set it. You have to clean it and cure it. So you can buy a UV clearing box. I built one. You need to clean it. You already mentioned resin is stinky. It's also sticky. It's also not very good for you to breathe. So you want to ventilate it. So I've got ventilation. Both of the printers have enclosures. My investment, because I bought the $700 printer, I probably spent $850 for my SLA printer. The resin printing, all said and done, I kind of did a quick adding up. When you get the UV and cleaning set up and some ventilation and all that, it comes in at around $500 is at least what I've spent. Software, let's talk a little bit about that. So I've gotten really into building some of my own stuff. So Tinkercad, and everything I use from a software perspective, I haven't spent anything. It's all free. So Tinkercad, you can do a lot. Very easy to use. There is Fusion 360. That is a full-fledged system. You can get, as a hobbyist, you can get a license for free. It's a little limited in what it can do versus the full-end one. But for our needs, you can do anything you want with it. The printers come with their own software, so I use the slicing software for the filament base that came with the printer. For the Anycubic, I use Chitabox. It actually does a much better job at slicing. What slicing is when you take a three-dimensional object and you want to do the additive manufacturing. The printers are, like your dot matrix printer, they print one row at a time. Each of those is a slice, and of course then it builds it up over, the 3 dimensions. So they call those slicers. There's also an open source piece. It's called the Photon File Viewer. And for 3D printing on resins, you really want to check how it's printing. I'll get into why in a little bit. And then you've got your consumables. You know, a PLA spool, my favorite to print in is PLA Plus. It's very easy to work with. A spool runs you from $19 to $28. And then resin, a 500 milliliter bottle of resin, anywhere from 19 to 22 bucks for the resins. That your traditional. Now, if you get into some of the exotics, prices can go quite a bit. So you're probably asking, okay, what does it really cost to print a part? So once again, these two pieces here, which was for my printing press, they cost me about 11 cents of material. So pretty inexpensive for a given part. That slide that I had all that stuff on my workbench, you know, so the tools holders, the paint holders, my tool stand, the little fan, I probably spent $2 in the filament. So the actual parts for printing, not that expensive. So it's really getting the hardware set up and getting the process set up. So if we look at my room, so what I have set up, and I'll go into these a little bit, but I have my filament printer and then my resin printer with the venting. This is a picture of my sub $200 printer that I started with. Very, very easy to use. It works really well. I also will say I've had customer support on all three of these printers. This one, they actually, I was having problems with the heating bed. They just sent me a whole new printer. With my resin printer, I would have, oh, did I lose you for a second? Am I back?
Yeah, we had a moment of audio dropout.
Yeah,
You're
that's what
back.
I thought. Okay. For my resin printing, I had some problems with the actual LCD display, and I interacted with them. Anycubic, it's overseas, so there was a slight delay, but no questions asked. They just sent me all the replacement parts, and it was really easy to swap out, and I was back in business. And then a similar thing with my heating element on this one. So I will say, if you go down this path, look at who you're buying, what vendor. Some of them are really good at taking care of you after the sale, and I'd happily recommend these three. And so if I look at my SLA printing or my additive, the filament, you really want to have it in an enclosure. It doesn't necessarily smell, but there are micro particles that come off when you do print. The other thing is you want to also control the environment. And then I've you know, 3D printed my own little spool holders and all that. But this is just, I picked up the IKEA tables for $9 or something like that. And I just, you know, got some plexiglass and built up some sides around it, and I had a box. So it doesn't need to be much, but you really want one. And then for my resin printer, this one's a little more elaborate. I have a base that has a vent on it, so the fumes kind of go down through it. So this printer comes in an enclosed case, but you really want to vent it. And then I have my UV cure box. I'll go into that in a little bit more, and then my cleaning station. And I did it again. Let me go. So we'll start with the vent. You really want to vent it outside. It is actually pretty toxic, the fumes. And somehow I zoomed in. How do I zoom out? There we go. Sorry about that. So I have a vent in the back. And this is a 3D printed part. I got that offline, and I'll show you where you can find some of these things. And then I have a little fan that it's just one of the computer fans I pulled out of something, and then a vent to go out the window. Absolutely want to do that. It's because it's stinky. I have one of those magnetic lab spinners. I bought that from Amazon for like 15 bucks. You want to wash your stuff in alcohol, 99% if you can get it. It was really easy to get pre-pandemic, not as easy now, but you want like pure alcohol. And then UV box. So I just bought, once again from Amazon, a UV light, and there's actually labeled very well, you know, this is good for resin curing and all that. And I just built myself a little wood box. I got some mirror material put on the inside, and then I got there's these cool little, for displaying, you know, rocks and jewelry or things like that. And they've got little solar panels on it, so they spin when there's light, so you don't have to put batteries in it. And UV light is perfect for that. So I just have one of those inside the box. I put my part in there. 20 minutes later, it's cured. So everything you can find it all, you know, on Amazon's one of my favorite shopping places, for better or for worse. But here's your little 3D printer UV light, and so that was 15 bucks. Here's your little spinners. I think I got those two as a 2-pack for 4 bucks. There's different versions now available. Here's the magnetic spinner, the little case. You just get all those nice parts. I didn't come up with all these ideas. There is tremendous amount of information out there. Thingiverse is like my favorite place. So this guy here on the left, that's what got me into a good way of venting. I didn't use his vent, but his cleaning stuff in his curing box is what he did. You know, I liked what he did, so I 3D printed his stuff. And then from the enclosure, once again, all the parts I printed with my printer, and I got the idea from, you know, somebody else. So, you know, credit where credit's due. They're not my own designs, but I did modify all the designs. Okay, so workflow for doing an FDM. This is your filament based. Find the part, design it, and I like to do prints along the way to test if I'm doing my own designs. You slice it. You got to make sure you got it in the right orientation. Add supports if needed. Figure out the resolution you want, the color and the material you want to use. So each material has different properties. So if you use things like ABS, it's harder to print with, but it's stronger. And also it's maybe not as environmentally friendly. PLA, which is one of my favorites, that is a plant-based material, not as structurally strong, but it's very easy to print with lower temperatures, but it doesn't hold up as well to UV lights. There is a question, sorry, I forgot to keep an eye on that. Yes, you really need to vent outside. I'm assuming that's what the question is. You can run it through carbon filters and all that. It's just far better to vent it outside. And yes, there are places that have 3D printers available, or friends. I actually print things for friends of mine as well. You know, if you have access to the, 3D printer, it doesn't have to be yourself to make all the investments. Resolution. So the state of the art for home printing of the fusion or the deposited, the filament paste is about 0.2 millimeters. That's probably the best you can get. And it does leave lines. And I'll show some examples of different parts soon. The workflow for resin, did I finish? Yeah. Oh, you print. It takes a while to print. So a piece that, okay, like the little brackets I printed for my NCE throttles, that probably took an hour to print. So you start the print and you wait. I have done prints that have taken close to 14 hours to print, big things. The resin printers are a little bit quicker because they're much smaller in parts, or that you print.
But by the way, Jonathan, just important to say there's a fairly big variability in FDM depending upon the quality you choose, the kind of thickness of the lines of each layer.
Yes.
Can be varied, and you can, if you go with fine layers, you can double the print time versus thicker layers, which is faster. So you can kind of deter a little bit with FDM of print time based on quality.
Yes, yeah, very good point. Thank you. Yeah, setting the print layer, and it's also true for resin printing. The resolution you select will dramatically impact print time, but that also impacts the quality level, the detail and how smooth the surface is, and it also has structural implications. And so even with the FDM printing, if you go through and do, a 0.4 millimeter print, so rather fast, the same part printed at 0.2 millimeters, the 0.2 is going to be a lot stronger because you fused more layers together. So it's things to keep in mind. And of course, once you've finished trimming and filing it, glue if you want. A company that makes an epoxy seal that you can paint over your FDMs or your filament-based printers to get a nice, super smooth, finish on it. And of course, if you have multiple parts, you glue them together. 5-minute epoxy is probably one of the best. I've started playing around with UV epoxy, and I'm really impressed with what you can do with that. And then prime and paint as needed, depending upon what you're doing. Most of my, FDM or filament-based printing, I don't paint. I just pick a color and I print and go from there because I'm doing more structural things with it. I don't do detailed parts with it because the resolution's not there. Now, if I look at resin printing, the flow is pretty much the same in the beginning, and that's find your part, design it, build, design your own, test as you do pieces of it. You go through a similar slicing, print orientation, how does it line up on the printer, supports. That is this is where it gets really important to have supports when you do printing. I'm going to actually show this piece here. That's that little printing press I did. Now, the thing with additive, and you actually ended up doing it this way, upside down. So we printed this layer first and kept going through. When you get to like this piece here, all of a sudden you have a piece that's hanging out in midair, and you need a way to attach it. So supports, you have to come in and make sure that, these pieces that are out suspended in there have supports. And I'll show what that looks like. But that's probably the trickiest part in resin printing is once you get into resin printing, I want to do more detailed parts and I want to have those fine details. All of a sudden you need to start thinking about supports. How do I print it such there's supports? Now the good news is the software does a lot of that for you. Okay, so you get the supports, figure out the resolution. Now we're talking in resolutions that you can go find enough you can't even see the print lines. Once again, time becomes a factor. And then the material, not as many varieties in resin printing. So there's your standard resins. There's now the casting resins and a few others. This is one area that's evolving a little bit slower with materials, I would say. And print times, it can be from minutes to hours to, 8 hours, half a day for even a resin print. Post-processing, and I highlighted this in red, this is where the two technologies go very different directions. You got to wash it in alcohol, 99% best. Then you remove the supporting material. You want to wash it again, and then you want to use UV seal it, and then maybe sand it, and that's where the support pieces were for the supporting material. And then you really want to wash it again, and I like Comet, good old-fashioned Comet. It's a little abrasive, but that really helps get it nice and clean. And then you prime it and paint it as desired. So that's one of the very interesting divergence between resin printing and the filament-based printing. Okay, next slide. So what have I learned? I've already stated this. PLA Plus is like the easiest stuff to work with. I absolutely love it. Air temperature is absolutely key. So when I'm doing my filament-based printing for PLA, you really want the air temperature around it to be between 100 and 110 degrees. I was struggling with getting things to stick to the plate, not have warping, layer separation and all that. And I was doing all my prints in that little box I built, and the temperature was about 90 degrees. I bumped it up 10 degrees, and all my printing problems went away. All of a sudden, I was having almost every print was working perfect the first time. And so that air temperature around the filament as it's printing makes a huge difference. Same is true for resins. Not quite as warm, but when you get the air temperature around the resin at around 90 degrees, it stays nice and fluid, and you get less air bubbles in the pieces. It just works a whole lot better. And so I actually built a little heater that's inside my resin printer, and I have a cheap little thermostat that turns it on and off, and I keep it around 90 degrees, and my printing got a whole lot better. Other thing I've learned, resin is very finicky to print with. I can whip up a part and print it with filament, start to finish for, a moderate piece, hour, 2 hours tops. Resin, I usually end up having to try and print it 3-4 times to get it to stick appropriately, the right supports. It's finicky. A larger learning curve. My newest learning is resin, unlike the filaments, it does expire, and the older it gets, it becomes more problematic. I was getting to very frustrated with my resin printing, and then I ran out and I bought another bottle of resin, tried to print, worked perfect the first time. And what I've discovered in reading some of the chat groups is as the resin gets old, it starts breaking down a little bit. And then ventilation, it's really important to have. I can't stress that enough. When I do resin printing, even though I'm venting outside, my hobby room stinks. And if I don't close the door, I hear from my family. And it's not really the best for you. Ultimately, I want to move my resin printing out of my hobby room because I want to be able to print. And that, when I print, and generally I start a print, I leave the room. The other thing, print samples. The other interesting thing I've learned, but never give up. If it doesn't print right, it's usually the environment you're printing in. It's not enough supports. It's something just, but don't give up. Keep going. And then my other one is on the filament based. Be careful when you change the spools. A couple of times I've had my line get tucked, and that can really end up in a spidery mess. The other thing in both printers, resin or filament based, you want to keep an eye on it for that first 5-10 minutes of a print. Most of my failures happen in that first 5 to 10 minutes. I've had failures further down the road, but if it's going to fail, you're going to have a problem, it doesn't stick to the plate, it's going to happen right in the beginning. And then if you go down the resin path, it's going to get messy. Make sure you have good, gloves and an area that if you spill some resin, it's no big deal. And I've also found the internet is wonderful. There are a couple of great websites that I hit this printing problem, pick, resin printing or filament based or whatever. And there's a whole list, well, these are the common things that cause that problem. And every time I've run into a printing problem, I look at one of my 2 favorite websites, see what the problem is. I make an adjustment as they recommend or that others have recommended. And 9 times out of 10, the problem has gone away. So, there is a lot of good information out there. How to find or create things. How long does resin go before it goes bad? Well, the good news is the bottles have dates on them, expiration dates I discovered, and they last at least the latest one I got, its expiration date is a year out. So it's about a year. Unless you do a real lot of printing, I would say a 500 milliliter bottle will last you. Well, you'll probably get through it in about a year, at least for me so far. How do you find or create items? So Thingiverse is one of my favorite places. and these slides, we'll get these out. You can get the links. My Mini Factory, find a lot of stuff. CG Trader and Finder, those are all, they have things that you can buy and free stuff. What conditions do I store the resin at for the best life? I keep them in a basically a dark closet, and they're in the coolest room in my house. So yeah, I would say I try to keep the temperature no higher than 70 degrees. And you really want resin cures because of light, ultraviolet. And so any light, they come in dark bottles, but any light that gets to it is bad.
I actually saw an interesting comment, Jonathan, on the internet where they said if you have old resin and you want to get rid of it, just leave it outdoors in the sunshine and it'll cure up hard after about a day.
Yes, absolutely.
So
yes.
Yeah, that's any light will kill it over time.
Yes, light, absolutely. And when I the first couple of parts I printed, I had, when I got the resin printed, my son and I were excited to print. I didn't have a UV curing thing. The way you cure it is you take your part and you put it out in the sunlight, leave it out there for an hour, come back, and your part is cured. So you don't have to have a cure box. You just need a sunny day. And so you want to keep your resin cool and dark. Those are all great places to find parts. Of course, Google, I want to find, whatever. And just put the word STL after it. STL is the common 3D modeling file. And you can spend hours looking for that part. And then when you can't find it, you go ahead and create it. I don't know if Tinkercad is moving to a pay model. Even if they did, there are a lot of free options out there. And so, but I like Tinkercad because it's so easy to use. And I can do a quick showing on that one. Fusion 360 has a learning curve, a lot of great YouTube videos on how to do different pieces, but it's a full-fledged. And so if you're trying to do something where, you got to get measurements right and things like that, Fusion 360 would be my recommendation. I'm actually learning SketchUp right now. I'm kind of working on a part or modifying a part, and the individual used SketchUp, and so he just sent me the SketchUp file, and so I've now jumped in and I'm starting to use SketchUp and learn that one. It's more powerful than Tinkercad, not as powerful as Fusion 360. Once again, you can get that one free too. And then here's all the links to all the different pieces. Let me just show the Tinkercad one. So if you go back to my printing press, one of the things is I needed a storage box. And so it is as simple as all the shape is, and it literally took me probably 5 minutes to make this piece. All it really is a bunch of blocks, and so you build a shape, and then here's another shape, and here this is a removed shape and a triangle. So it's just a collection of shapes that I quickly threw together. Is this exactly prototypical scale? For what I was trying to do, I was going for the impression. So I just threw a bunch of shapes together, and then I resin printed it. So I spent 5 minutes on this piece and printed it, and an hour later, I had what I needed. And so you don't have to, go crazy if you can't find things. Let me go through a design walkthrough. Do we have time for that? I wasn't sure how much time I had.
Sure, I think we're good, actually. We're good.
Okay. So let me walk through my whole process of this particular building, which I showed off a couple weeks ago or maybe a month ago, which got me roped into this. How did this come about? So I built this model. You've seen this picture before. I had a blank room in the back. I needed my printing press. So I went and did my search. I said, okay, let's search for a printing press. And I searched for, printing press STL, and just in Google, all types of cool stuff. spent probably about 30 minutes looking around for different ones, and I found these two that kind of caught my eye. And you'll recognize the one on the right because that's the one I ended up doing. This one was kind of cool. This is somebody did this model, and this is an actual one that kind of works. But I like the format. But then I stumbled across this one, and I thought, wow, that's exactly what I'm looking for. And this is the model. Just a beautiful piece of work that this person created. So from that, wrong side down here. So there it is, found it, wonderful, beautiful piece. Now I need that cabinet, and I searched and couldn't find it, so I built it, and I showed you that piece already. It's just a simple piece that's just a collection of squares, rectangles, and it's very easy to use, make little groups. So I built up this piece and this piece as groups, and I just copied it, spaced them all out, you know, a couple millimeters apart from each other, put a triangle, put 3 boxes on it, and voila, I had the piece. Now, scaling it. So you drop these shapes into your favorite slicer, and you go through. In this particular one was way too big, the printing press. But that was okay. I just said scale it down, so I put the 2 pieces on in a nice scale. Now, supports. For this piece here, as I mentioned earlier, when you have overhangs like this, you have to support it in printing. Printers, if you print something in the middle of nowhere, it's going to make a mess out of stuff. So I told the software, there's a simple little button that says add supports, and I said add supports, and it goes through and it calculates and looks at where are all the overhangs that it needs support, and it adds them. What I typically do is I add the supports, I print it, see how it comes out, and then maybe I'll go in and modify some of the supports because, you know, software is not perfect. This particular model, it supported perfectly. First try, it took me 1 try to print this. So once you get the supports, you want to go through, slice it, and then verify. And in this little picture here, so the software has this tool that you can go through, and it shows you layer by layer. You can run it through and play and watch where all the dots are, because you don't want to have while it's printing. And basically the way this printer works is you have a vat of liquid, and it turns on a UV light. In the dark area, the UV light won't get through. The white areas, the UV light will get through and adhere and create an adhesion to the previous layer. So if you end up having a white layer that just appears out of nowhere, it's now going to create a solid piece of material in your vat of resin that's going to float around and stick to something, and it can get messy. That's where the other piece of software, the photon file checker, comes in. So you can manually go through and scan this. There's a little piece of software, somebody wrote a piece of code that just scans the output file and looks for a random, here's a piece and there was nothing connecting to it. And it just flags them so you can go in and fix those. And so once you do that, you go into the printer and start the printing. As you can tell, it took 2 hours and 49 minutes for that printing press and the bookcase to print. Now, let me talk about the times a little bit. There's obviously the resolution adds to it, but one big difference between filament-based and resin-based printing. Filament, the bigger the part is, or the number of pieces you put on the printer plate, because you can print multiple parts at the same time, every part, every piece on a filament-based printer increases the time. With resin printing, it does not. It's really the height of the unit. So if I'm printing 1 piece or 10 pieces, if they're identical in size, the printing 1 versus 10 is the same amount of time. So that's another little interesting, thing about resin printing. Once you get your piece out of the resin, you wash it with alcohol. Then all those supports, So my bookcase thing for the printing, press pieces, there were no supports needed for that. But this, there was a lot of them. So you want to come through and just break off all of those supports and cut them. And various tools I use for that. Typically, the side cutters as well as an X-Acto knife, and you just break off all the pieces. You want to do that before you cure it. Once you cure it, it becomes brittle and very, easy to crack and break. When it comes off the printer, the UV light, because it's only exposing it each layer for a couple of seconds, maybe about 10, 15 seconds, it's hard, but it's still very pliable, and you can actually bend it. So, and it's much easier to cleanly clean up the unit. Once it's all done, I washed it, and then I hardened. Now these two pieces they're ready for painting, and they're brittle, hard, because they've been fully cured. And it takes about, I like to cure mine for about 20 minutes in my little ultraviolet cure. And then I prime them, and then I painted them, and there are the two finished pieces. Which, you can't find this, to buy per se. And now they're in my nice building. So what I'm actually going to do, I want to show some parts on the camera. So let's see if I stop share. And does my video become full?
Yeah.
Yep. Okay. So let's see if I can, actually, I'm going to move the camera. And so this was a sample part. And so you can get some very interesting shapes with the resin printing. You can't machine a piece like this. Here's my little linotype, or the printing press. The camera's not really focusing in that well. Detailed figures, so my son's into gaming miniatures. So there's a nice little miniature, but
okay. I'm getting washed and dressed.
And then here's a 3D printed horse. Yeah, this is actually, I think it's Alpine Models. They are now selling 3D printed pieces. I'm in the process of building a stamp mill. I couldn't find Grant line windows of the size I wanted, so I went into Tinkercad and I designed up my little windows, and I printed all of those, and it probably took me about 20 minutes to print all those windows. And here's a bookcase that I printed. It's sticking to my piece of paper. So a standard little bookcase. Get a little light. Now, I had, back to my stamp mill, I lost one of these. I don't know what happened to it, but this is the Whiffley table. And I talked to Western Scale Models. I forget the guy who owns them now. And he doesn't have them. He's looking around for the molds. I actually just, in Tinkercad, took measurements off the metal piece and threw it up in Tinkercad, and I printed myself a resin one. So I created my missing piece. Let's see. Oh, my little filing cabinets. These are all resin printed. So everything here is resin printed. And as you can see, very fine details at a very small scale. And the filament-based printer, you can't print something like this because the resolution is just too big. So that's examples of what you can do with resin printing. And like this piece here, with Tinkercad, it probably took me about an hour to get the base. I printed it, and then I found mistakes with it, spent another 10 minutes, 20 minutes in Tinkercad, fixed it up, and then I was done, and I had a piece. So if you've done any type of drawing on paper, working with Tinkercad or any CAD system is not that hard. Questions? Let's see. Nothing else in the room. And you have my email. Anytime you have questions or want more info on software or your example of how to use some of the software, I'd be more than happy to help you guys.
I think that was excellent, Jonathan. Thank you.
You're welcome.
That
Would
was
it be
outstanding.
a good material for trucks? No, I don't think a resin would be good for that. Resins, well, at least I'd have to look into it. The resin I'm using is too brittle once it's cured. So it becomes very, there's no play in it. You know, any little motion in that would crack it. However, there are new resins coming out. And so there might be a good resin for that now, a softer or a more pliable resin.
Hey, Jonathan, so if I've been using, Shapeways to have parts printed, I figured that they have a lot better printer than I can buy at home. But from looking at your presentation, it looks like the resin printers are getting pretty close to the Shapeways quality, at least for things we need for models.
So yes, so I've printed a lot from Shapeways. So that Saturn F1, actually both of them that where I showed, I got from Shapeways. And the detail level on those is outstanding, and I got those years and years ago. I'm getting the same resolution of that off of my printer. That was from Shapeways at a fraction of the cost once you factor out the investment of getting the machine. Now, what Shapeways offers that home printing still doesn't is the variety of material that you can actually get things in. So back to the question on the truck. I'd have to look into what resins are available nowadays that you can print with it. But I know Shapeways has material that you could print the trucks from. And a recommendation for starting. What do you recommend for what? Starting which? From the chat window.
So I think the question probably is more along, if you're just starting out, which is better, resin or FDM, and, et cetera.
Yeah, okay. So that's a good question. So the filament base or the FDM is easier to start with. And so that's where I started. It's very forgiving. However, what you want to print from a modeling perspective, so if you want to print things for your actual layout, I don't think the FDM or the filament-based printing you could do anything with, because you can't get the resolution you need. If you want to do printing of parts for your layout, detail parts, for buildings or outside handles, whatever, you're going to have to go into resin. Resin is harder to learn. I would still consider myself a novice on the resin printing, because I'm still running into, that didn't print quite right.
So John, just a comment. I actually, as part of when we get to it, I've got a couple of slides on. I bought an FDM printer because they are under $200 now, and I think it's probably maybe a good way to learn, because you end up printing a lot of things, and it turns out scale is actually interesting, because when you get into O scale, there's more you can print.
Good point.
Because it's basically volume, so you're double in 3 dimensions. So a part in O scale is actually not twice as large, it's 7 times in volume larger in the 3 dimensions. So when you look at essentially display dimensions, you've got a lot more room. So I think if you go to G scale, you might find there's a lot more you can print on a filament printer than you can in N. I mean,
That's a very good point. I forgot about the scale aspect. I'm one of those weird SN3 guys, and so small is good.
yeah. Cool.
But yeah, it's learning in my initial learning how to 3D print, the ramp time on the FDM or the filament based was really fast, and when I got into resin printing, it was like starting all over again. And it's been taking me longer to get good prints out of the resin printing.
Cool. So for those of you who haven't, if you're interested, I've put a few pictures up of stuff that I printed. So I bought a printer. It's only been about 3 or 4 weeks, and so let me show a few prints. I'm going to throw this in. So this is that Moss Landing module I'm building, and hang on, let me go back here. Go back one. So if you look here, because again, this is ON30. On the left, where that dock is, those are now some 3D printed items, and then I'm going to show you the trusses for the roof in this building. So this is actually the dock. So I'm trying to recreate as the scene on the left, on the right. The building is actually just a paper printed building as a stand-in. So I had to create a couple of coffin fuel tanks, and then there's a longer fuel tank you can see there. And so basically the idea was once I got the printer, was to use it to print those pieces. So this is actually a close-in. What you see on the left is and literally, this is after 2 weeks to be able to print some of this stuff. So I think Jonathan's point is on the filament, it's $200, and you can actually do things that start to get pretty interesting pretty quickly. So the left is basically the coffin tanks, and one of the challenges was trying to get the slant on the sheet at the top. The one on the left has actually had some squadron putty put on it with some acetone to thin it out, to smooth out the lines, because you can actually see on the one on the right, those are the lines you get with the filament printer, because those are actually the layers, and this is actually running at 0.12, so it's at the finest resolution of the printer. The legs, actually, as you see on the right there, were printed. Those are printed, they're unpainted at this point, but they're printed as 2 separate pieces that glue together, and then the feet that go on. So these are actually the pieces there. What you see on the left are the pieces that, little piece of PVC pipe for the tank. I'm going to wrap around where the connections are. I'm going to put banding so you won't see it. And then the little legs that are created, and those printed actually together. What's interesting, and you can't see this very well on the right, on the lower picture, you can actually see the lines of the print head. On the upper picture, it uses this learning curve, a thing called ironing, which actually uses the print head to smooth out the print and really smooths things out a lot. So you can actually get rid of a lot of those lines. This is another example. This actually is an acrylic framed building. I'm trying to build these very strong because they're on a module and they're actually all removable. The roof is acrylic. It's got a couple of little tabs that slide against the roofs on the end to keep it positioned. But I wanted to put trusses in it and decided it wasn't worth trying to put wood trusses in. So those are actually just 3D printed. So basically the plexiglass on the roof is scribed. It has some texturing on it and then was painted and dry brushed. What's interesting is if you look on the line on the roof there, that's actually on the interior. It was put lines on the outside where the truss was going to be, then taped on the inside and painted it, then took the tape off and you could see where to glue the trusses. So they're actually glued in place, and then some, we talked about this, some paper gussets there on the trusses. And so they're going to go in here and you'll just see a little bit of them. I ended up deciding to use FreeCAD. It turns out there's a pretty good controversy going on right now around Fusion 360 because they've changed their free licensing. Tinkercad is actually a free program of AutoCAD. They sell to schools or give to schools and that, so that's probably not a problem. But trying to create complex shapes, Tinkercad's great for boxes, but trying to create complex shapes is a challenge. So this is actually kind of the process of creating in FreeCAD. To create this thing, what you do is you create a series of sketches, and then you grow the sketches in the third dimension. So it's kind of, if you look on the left, on the top is the part. If you look where it says pad, there's a sketch. That's the sketch on the bottom left, which is actually part of the truss. And then you add in the other individual pieces, and each one is an individual little sketch and gets grown, and then they're combined together, and that becomes the print. So you can do, a lot of really complex sizes in it. And then this is back to the same thing that Jonathan talked about, where you put it into the slicer. This is the slicer that comes with the printer I bought, the Creality, or you can use Cura, which is actually the Creality's one's based on Cura. And you can just put the parts on the print bed. And what you saw with Jonathan, you put a bunch of parts on there. The other thing I found was at the OSCO group in Pleasanton, we're building a test module for CTC signaling. And because it folds up, you can't use full-time size signals. So again, going back to Thingiverse, I found a signal on Thingiverse that had this really nice head. And what I wanted to use was the cover, light covers there, but I couldn't have something that stuck up because when it closes, the two parts close up as a clamshell, and the space for this signal is only about an inch and a quarter. So what I did was design this little part here that actually holds that signal head and then holds two LEDs. And so this is actually what that part looks like. I think, John, this comes back to the point is the cool thing about these tools, especially when you get into the CAD tools, is you can design really interesting, complex shapes. And once you understand the concepts, they're pretty simple. So this shape here is actually this rectangle down here, which is actually on as a drawing, and then this oval shape up here at the top, and you just use a real simple linking command to connect those together. And so if anybody's interested at some point, show you how to do this. Once you kind of learn the concepts of this, it's really easy to design complex shapes. So my printer's just out in the open. What Jonathan said, the first thing you do is you print lots of pieces for it, and then you print lots of stuff that you throw away. So I think it's pretty interesting that you can start this. Somebody asked the question how to get started. I bought the printer, it was $189 delivered, and a spool was $22. So I think for $212, you basically are starting out. And by the way, the first thing you do is you print a bunch of stuff for your printer to make it more effective. Go online and go watch some YouTube videos. So pretty exciting.
Yeah. So I wanted to share this real quick. Since you're printing with the filaments, this is a product that you can brush on to parts. It's a resin specifically designed for 3D printing things, and I've used this. And if you instead of trying to sand a piece or fill it with putty or all that, you paint this resin up, and you get this perfect finish that's really great for painting and works great. So I highly recommend that.
Cool. So throw it open. Anybody else have, is kind of anybody else playing with this, have anything that they're interested in kind of showing and talking about?
Hey, Jonathan, I do have one question for you. I'm looking at doing some 3D parts, and it's going to mimic a wooden framework, for lack of a better way to phrase it. Is there anything out there about creating texture on these parts? Because it looks like all the parts try to come out looking like smooth metal.
Yeah, so great question. So I'm in the process of trying to design out a boiler for my mill, and I wanted some part of it, some like a wooden deck around it. And actually in Tinkercad, because I'm still using Tinkercad for that particular piece, there is a wood texture. And so I just included that wood texture, and it automatically had like this grain pattern in the part. So yes, you can absolutely do that. I was printing all smooth stuff because I wanted smooth stuff, but you can.
Cool, thank you.
Yeah. Yeah, it's 3D printing it's a fascinating technology. One of the interesting things, because my son's into the miniature gaming, we found this piece. It's if you're familiar with the game Gloomhaven, you've got these counters and little pieces that you put on, and they had cardboard stands, and then you had to keep track to the score on this other thing. Somebody came up with a 3D printable part that you print as one piece, and it spins and moves, and there's no way you could make a piece like that that you wouldn't have to glue or snap together, but the printer just like prints this piece that is movable with locking rings and everything in one shot, and it's a fascinating engineering effort in that. And I looked at how I reverse engineered it. It's mind-boggling what you can do with this technology.
Phil, this is Jerry Ingram. I mentioned last night when we were talking at ACCRS about a project I was working on that involves 3D printing. Would you like to take a look at it?
Sure. That was, I kind of thought it was a great chance to have folks show what they've been doing as well.
I apologize about being a little late to your meeting. 9 o'clock is usually a little early for me, okay? Hence I'm in my bathrobe and coffee cup. In any event, I hope you guys can see this. This is a project I've been working on for about the last 2 months. The actual 3D printed part is this roof. This is an effort at replicating a Western Pacific coach, and this is this particular set of parts right here are really this is actually an Eastern Car Works Pennsylvania P70, which was the basis for what the WP used to make a 70-foot coach. The only problem was that the Penzi used cholesteroid roofs, and the WP had a Harriman roof on it. So what I've done is I've created a Western Pacific Harriman roof, which you I hopefully can see in this image right here, and it fits on the Eastern Car Works kit. And our first effort was, and I'm going to turn it off to one side so you can see the, hopefully you can see the detail. And this was actually printed by Shapeways. And they did a pretty, and this is what they call their FUD, F-U-D, fine ultra detail, which is not the most, not the finest detail that they make, but it's the second finest, I think. And this was actually an interesting project in that the roof is one part, and then the car, you buy the car kit from, you get it online from eBay. There's a number of these sitting around out there. I think Eastern Car Works kits are still available, but this was a kit that was produced back in, I guess, the 60s and 70s. And so you don't have to print everything, but you can buy this for a few bucks, and then you have this, you can print up your roof and put it in place and put it on a car and get a very accurate representation of what the WP car looked like that was used in the Expo Flyer, which is what this car is designed to kind of complement. One of the reason I got into this is because I had a brass model of this car and it got stolen. So, and I've been unable to find a replacement. So I'm into having to build one based on these particular dimensions. But it's been kind of an interesting project. The roof has been, needs a little more work. It's not quite long enough. There's shrinkage associated with 3D printing, and how one goes about calculating that is kind of a dark art as near as I can figure out. So if anybody's got any ideas out there about how to calculate shrinkage associated with 3D printing, I'd appreciate knowing about it. And the other issue is one of, I like what the previous gentleman mentioned, is that there's a material that you can now spread on that fills in the less resolution. And the fact that the 3D printers, it takes care of the gaps that are formed as a result of filament type printers. So I thought that was kind of interesting. I didn't realize that was available. But anyway, I thought you might be interested in seeing this.
Yeah, one of the things, by the way, I'm going to ask Jonathan to do is to grab a bunch of those links and send them to me, and I'll try to put those in the YouTube video when I post it. The links to some of the, there's, if you can just put all that in the text in the YouTube video, put a bunch of links in there so they're there. Yeah. By the way, one of the things I found when you go look at YouTube videos of the printers, And here I wanted to show you this. This was, let me put up I'll put up a real quick share here. This is, so this is from Thingiverse. And that's actually a crate on Thingiverse. And if you look over here, these are actually some I got, and I did not design these, but printed, that actually have that, have wood grain built into them. So again, I think it's depending on the CAD system you have, you can add that in. And those were actually with a filament printer. Those are, they're probably about a 1/2 inch square on the end, and it actually doesn't look too bad. And by the way, I'm becoming 99% convinced you have to buy a resin printer for modeling, but I still think
Yeah, I was going to say you're going to want both.
Right.
I use both printers quite a bit. They each are used for different types of things.
By the way, one of the interesting things on those trusses is because they're laid up, if you think about it, they're printed this way. So when you look at the edge of the truss on the bottom, it actually has the layers on it, and it actually almost looks like really straight wood grain. So, it's kind of interesting. That side of them actually doesn't look that bad necessarily.
So what I've been playing with is I have a spool of wood-infused fiber, and you can stain it because it's got wood in it. And so I've been playing around with, how do you stain the filaments that have wood in them? Now, unfortunately, the one I got has a bamboo wood in it. I'm going to go back and buy something that's a little more stain acceptable. Bamboo doesn't like to stain.
That's fascinating. Phil, with regard to the resin printers, what is the largest platen that's currently available, i.e. the surface that you could use to print on, and do you know a manufacturer?
Well, Jonathan, I can throw it to you because I think you have the Anycubic, and I don't know how big the platform is on it. It's
200 by 400 millimeters. Sorry, 200 by 200 millimeters. No, that can't be right because that's 20 by 20 centimeters. That's not right. It's like 3 inches by 4 inches is its printing surface. But they've now come out with a new one that has like double that size. The resin printing, actually, what is the limiting factor or the most costly piece of it is the DLP screen they use that blocks out the UV light. And having one that's resistant to UV light, that's the piece that's going to wear out in a 3D printer, a resin printer, is that DLP screen. And you probably get a couple of years out of it, and then you're going to have to replace the screen, at least with today's technology. But that's the limiting size.
But I would suspect that technology is continuing to improve and move forward, and also a reduction in cost as well. So I'm looking for stuff that's roughly about 12 inches, rather than having to send things off to Shapeways or one of the other printing houses. But I need at least 12 to 13 inches in length, and at least maybe 12 to 13 inches in width, or an appropriate, any idea when that would be available, or have you seen any products that relate to that?
Yeah, I mean, those printers are available, but not at the hobbyist price point yet. My guess is we're a couple of years away from a hobbyist price point for that.
So kind
would be my best guess.
To give you an idea, the Photon, which is the resin printer, is 115 millimeters by 65 by 155. So it's 4.5 inches by 2.5 inches by 6.1 inches high. So the build plate is 4.5 by 2.56. That's the $170 Photon. The resin, or excuse me, the filament printer is 220 by 220 by, I think, 200 and something, 240 or 250. So it's about double the size. And then today you can buy, for probably about $100 more, you can buy a 400 by 400 filament printer. So if you kind of think about from a technology perspective that the size and that they're probably 2 or 3 years ahead, it's probably going to be a couple of years before the resin printers get up to that size at a cost point.
Yeah, so Anycubic does have they have now a what do they call this, the mono printer? Yeah, the mono printer. And so it's a 200, the build volume is 130 by 80 by 165 millimeters.
Right.
So that's their largest one.
So you get about you get about somewhere close to double the print area in each dimension, which again, because you can put parts 8 times the volume at the same cost point today on a filament printer versus resin. So resin is probably a lot better for smaller parts.
Yes. Yes. Unless you do 2 pieces that you put together. Which I even with filament printer, I've been doing that. So I do have an air filter on my filament printer in the box, and I 3D printed that for the HEPA filter, but it was too big for the printer bed, so I just printed an A half and a B half, and they had locking tabs that, I glued together, and I was good there.
Well, very interesting stuff, to say the least, as technology moves forward. Just out of curiosity, for a resin printer that is at 12 by 12 inches in length, at least the bed length, 12 to 13 inches, what's that cost point at this point? Do anybody got an idea?
Well, here's the one that I'll just show you a picture. This was the one that Jonathan was, I think, referencing. This is the new Anycubic larger, faster 4K. So these things, what Jonathan said is, in the bottom of this, down underneath here, there's actually basically a screen, an LCD screen. Mm-hmm. And it's generating light going up, and there must be another layer of light, and that's how they actually get the points to congeal. So this is using I think this says it's using a 4K screen, which is what you need to get. If you make it bigger and the screen resolution stays the same, then the resolution of the part actually gets less. So to make it bigger, they had to go to a 4K screen. So if you look at the specs on this, the volume is basically 192. So, that's, what is that, about 8 inches in that dimension. And this one's 750. Pre-order 760. It's a new. So I think the problem in the resin, to get that large, you're going to have a real problem with cost. You're probably over $1,000 easy.
Oh, yeah, absolutely. Talk in the order of like 10,000. So, a buddy of mine works up at HP Inc., which is building the professional grade ones, the ones that like Shapeways buys. And actually what they do is they'll take that 4K screen, and just like the big screens that they have in stadiums, they're actually a bunch of little screens put together, and then they're all synchronized. That's how they make the big printers. And so now you've got a bunch of those screens, because you can't like print one part and move it. It's got to be entire layer at a time. And so they basically put a bunch of those screens together, then through some fancy controller boards, get them all synchronized so they can print those big parts.
So do they need a mass of parts to print to test that we could submit to test for?
I am exploring what I can get out of that.
I mean, we could probably provide them some unique stuff to print to test.
Exactly. Yes.
Well, I think that's probably kind of the end of this. I think we'll probably go ahead and wrap this up, this section of the session. I hope that was interesting. I think it's a phenomenal opportunity for modeling, both sides, the filament and the resin printers. So hopefully everybody gets a little bit of experience out of it, and we'll come back and visit it again in another day.
Yep, and if anybody has questions or thinks of things, oh, I wish I would have asked, I threw my email in the chat. Feel free to reach out to me. I'll be happy if you got software questions, printing questions, run into a problem.
Cool. So the last thing I wanted to spend a little bit of time on today was getting any input from anyone for the PCR board meeting this afternoon. Bob's here. I'm here. Take those inputs in. The one input I've had is everybody's getting excited about the convention next year and getting signups. We've got that. Is there anything else that anyone would like us to bring up relative to the PCR, not from a Coast perspective, for later today?
Yeah, Phil.
Yeah.
We usually have our meetings when we have physical meetings on a Sunday morning. This is impossible for me. Is there any possibility of maybe afternoons or Saturdays?
So that was actually something I wanted to bring up, because we kind of picked this time kind of by serendipity. It does exclude anybody in Hawaii who doesn't want to get up really early in the morning.
Yeah.
And I kind of am cognizant of that. We've kind of shafted those guys by doing this. One of the thoughts was that, is there an interest in moving this to a different time? I mean, clearly we do. We have done normally our meetings on Sunday. I'm very open to doing something at 1 o'clock on Sunday, kind of an after church time, like we used to have, our events, physical events. Kind of open it up, just kind of for comments there. Last time I did this, there was a general agreement this was a good time for most folks. On the other hand, I know it's really an impossible time for a few folks.
Yeah, and I'm not opposed to doing something to accommodate them.
Right. So this is kind of last time I did this and had this, there was kind of the loud thud of no one saying, yeah, that's a great idea, because I think folks kind of like this time frame. So
Well, I do like this time frame, but I think we got to, like you say, think about the guys in Hawaii.
So our next event will be in a couple of weeks. Do we want to try to do that on Sunday? So a question that's interesting, if we move this to Sunday at 1 o'clock, kind of, can anybody who can't come kind of raise your hand or click on, there's a reaction thing at the bottom. And so, like, if you can't come at 1 o'clock on Sunday, click on the cry icon there on reactions. You can cry. That way I can see how many folks. So we're going to lose at least a couple of folks on Sunday. How about, so is that, anybody who didn't say they can't come, is that a reasonable thought process? Should we try that for 2 weeks from now?
Phil, for me, I find that there's a lot more conflicts on Saturday morning than there would be on later Saturday, maybe even Saturday evening.
Saturday evening is the other option. We could do it at 7 on Saturday evening. There were a few folks back that said that was a problem, but that may have been fairly early on. So maybe we should try 7 o'clock Saturday evening next time, and then we can try it once in 2 weeks from now, and then we can decide what we want to go back to after that. I'm open either way.
Works for me.
The bad news for me is every day is Groundhog Day. I mean, it's been Groundhog Day for 6 months. I cannot believe the fact that we've been in this CRAP for 7.5 months.
And counting.
And counting, and we had 130,000 people get this stuff, and we're still in this situation. So,
Bill,
oh well.
I think the OPSIG meets on Sunday at 1 in the afternoon. They're at 4 o'clock East Coast time. So
yeah, I think you're right.
One conflict with doing it on Sunday afternoon.
I don't think there are any 7 p.m. Saturday conflicts, because all the East Coast guys are done by then.
Mm-hmm.
So why don't we try that? I'm going to try that for 2 weeks from now. And I know we had a couple of folks that said they would miss that, but let's try it 2 weeks and see if you can make it. And we'll see kind of at the end of that, we'll have the same discussion just like we had now and decide whether we want to keep doing that or move back to the 9 o'clock time. You know, like I said, my goal was really to accommodate the maximum number of folks being able to come. Cool. So that's kind of for us to decide. I think that's the decision. So when I send out the next, when I send out the next Coast Extra next for Thursday, Friday, I'll note that the next time we get together, we decided to do 7 o'clock in the evening. Any other PCR inputs? Cool. Well, then I guess with that, we'll throw it. Is there any last things anyone wants to share, or we will call it a day?
Interesting session, Phil. Thank you very much.
Thanks, everybody. And by the way, Jonathan, thank you. That was superb. I mean, just brilliant. I guess the only question I would ask is, do you see any reason to have separate enclosures? Or can you put them both in the same enclosure?
Yeah, you could put them both in the same enclosure. The enclosure is really to manage the temperature and the smell.
Right.
And if you're printing only one at a time, then who cares?
Right. I'm actually going to put them in the garage. I've decided after thinking about it that having a nice place in the garage is the best place to have it.
Yeah. I would recommend having the printers not in your primary modeling area.
By the way, the filament printer is not bad. It's actually in a room. It's in my train room, sitting on a table there, and it's not bad in that space. But the resin printer, I can understand is really bad.
Yeah. Well, and so yes, my filament printer does not give off any odor that I can tell. But I've read enough articles on there are microparticles that come off of it, and it's not conclusive what that does to your lungs. It's just like when you airbrush, you should wear a mask. It's a similar concept. So yes, they do not smell, but they're still trying to figure out what comes off of those things.
Wow. That's something to think about. Now that COVID susceptibility then.
Yeah. And so I opted to put mine in a box, and it has a HEPA filter on it because I figured that's a small investment.
Yep. Excellent. Well, I'll bid everybody a good week, and we'll plan on 2 weeks from today, which is I think the 21st at 7 o'clock p.m. And we'll all be together then. Thanks, everyone. Have a great week.
Thank you, Phil.
Thanks.
Thank you,
Thanks.
Phil.
Thank you, Phil.
Bye now.
Hey, Phil,
Yeah, thank you, Phil.
you still there?
Thank you, Phil.
Yes, I am.
Yeah,
great
when you're printing
presentation.
with PLA filament, you're not going to smell anything, but if you're printing ABS, you don't want to be in the same room with it.
That's a good point. I've only done PLA. I've never that's a learning I haven't done ABS.
Yeah, I do a lot of ABS for the G-scale stuff that's going to be outside. Because the ABS is UV resistant where PLA isn't.
Right.
Yeah. Yep. And if you print with like the filled ones, which I've done, they give off a nice burnt wood smell which is pretty potent.
Yeah.
Oh, well. So we have to ventilation, and the other thing I've heard with resin is that you have to have lots of gloves. You go through gloves like mad.
You do go through gloves. I've read that the resin burns your fingers if it gets on it. I've gotten it on my hands, and I've never been burnt by it. It's sticky, and it's hard to clean. And so it's just best to wear gloves.
Cool. Well,
Did
thanks
you have
again,
any
everyone.
unanswered questions about the next year's NMRA convention? Were there any unanswered questions?
I think the only question just was when the reg was going to be open. I think you pretty much answered that, and we'll probably give an update in 2 weeks.
It's very soon.
Yep.
Yeah,
Cool.
I'm the temporary registrar.
I had talked to Frank Markovich about possibly doing a clinic, and he said they don't know for sure, of course, at this point, whether the convention's actually going to happen. I imagine that would also be true of the a mini convention, the regional convention.
I would assume so, and it's actually earlier in the year, so it's probably even more challenging.
Right. I wonder, do you have any kind of a timeline, or is that something you could discuss at your meeting about when you can let us know a decision on that?
Well, I was talking to Bill Scott, who's taken over as chairman yesterday, I think it was, and he's very interested in kind of joining our next meetup, and with the idea of kind of letting everybody know what they have planned and what the status of things are. So that would be a good opportunity to hear it from the horse's mouth, so to speak.
Dave, that's great. Can you, when you talk to him or ping him, let's get in contact for 7 o'clock 2 weeks from now.
Good.
And we'll plan that on the agenda. And by the way, I am still looking for more content for someone, a layout tour, take some pictures. We will. I think the 3D printing thing was great. The other thing that I need to go back, someone had done some work with Cricut. That's the other tool. I mean, I think these kind of modeling tools are interesting discussions because people are thinking about them. The investment cost is getting pretty low for a lot of these. So,
If you'd like, I'll talk to Ray Davis. Ray was going to do a presentation at the PCR convention we didn't have. I'm sure maybe he might be interested in doing something here at the meetup.
Yep, that'd be great. And I'm talking to Frank about, Frank's also going to redo, he did a quick clinic on the layout that they built for the State Railroad Museum for the NMRA display. And I've asked him to redo that as well. That was basically a PowerPoint presentation. And the other thing I was actually thinking about, Seth actually did a clinic on designing cards using some software for printing circuit board cards, and he's got this capability of creating mini circuit board cards. We're actually looking at, for the Pleasanton Club and for our signaling, actually having little circuit boards mounted below the signals and then have a plug, and so all the signals are going to be installed from under the layout. So you drill a hole in the layout where you want the signal, put it up from underneath as a plug unit with the connectors on the bottom, and all it's going to have is an RJ45, and you plug in a Cat5, and that runs back and terminates into the either the Chubb system or a CP node for the CRMRI. And building those little boards is really easy once you understand how to use the software. So I don't know if there's an interest in that as kind of along the lines of the 3D clinic. I think the Cricut and maybe the board manufacturer are things we can schedule in over the next couple of months. By the way, I laid these out for the schedule through the end of the year. I have a funny feeling we're going to be doing these through February or March. I think the probability of a physical get-together in the first 3 months of the year is looking less and less probable to me. And I'm not trying to be alarmist. I just don't see a probability.
Yeah, I know. I think it would behoove us to be very conscious that it's going to be a while. I've got friends who work that are actually involved with vaccines and stuff, and don't read everything don't believe what you see in the press. It's going to take more time.
So again, anything anybody'd like to talk about, send me an email. Because I think it's, because it's great to have, well, it's fun to have the social discussions like we have. I think it's also fun to have something that gives us some education and information and learning. So excellent. Well, I'm gonna jump. Actually, we're going to be working on that Testerville thing. I'll show a picture of that next time. We're building actually a training aid to train how CTC systems work with CMRI, and also how to use the layout once you have real signaling on it. So it's going to be kind of interesting to try to train a bunch of folks on how to use these things and deploy them. Cool. Well, everybody, I will bid everybody adieu and have a great week. Thanks all.
Bye, Phil.
Yep, thanks.
Bye now.